With a glass tube and a slice of potato, you can make a gun that actually shoots. Would you like to know how? Then keep watching.
Hello, young neighbors. Welcome to Junior Science. Today, we're going to talk about gases. First, what is a gas? Well, we know that everything in the world is made up of tiny particles called molecules. In a solid, the molecules are held together very closely. A solid has a definite shape and size of its own. In a liquid, the molecules are held together less closely. A liquid takes the shape of the container into which it is poured, but does not change in size. In a gas, the molecules are held together very loosely. A gas has no shape or size of its own. It spreads out until it fills any closed container into which it is placed. We know that solids and liquids have weight, but gases are pretty thin stuff. Here's an experiment you can do to show that even gases have weight. Put a little carbon tetrachloride cleaning fluid into a deep container. Place the container in a dish and pour hot water into the dish. Let them stand for 5 or 10 minutes so that the carbon tetrachloride will evaporate and become a gas. Then blow some soap bubbles into the container. Instead of falling to the bottom, the bubbles appear to be floating in midair because they are supported by the carbon tetrachloride gas. So we see that a gas has weight. The air that is all around us has weight and is pressing in on us from all sides. If you want to see air pressure in action, just try this. Ask a friend to lift this bottle without touching it. He'll think it's impossible, but you show him how. Just set fire to a folded paper napkin. And drop it into the bottle. Immediately put a balloon on the mouth of the bottle. In burning, the napkin forces some of the air out of the bottle. When the inside air cools, it shrinks, and so it has less pressure than the air outside. So the balloon is pushed into the bottle by the air outside, and you can lift the bottle without touching it. One of the reasons we can drink soda through a straw is that air presses down on top of the soda and pushes it up into the straw. If you want to see this for yourself, open a bottle of soda. Add a little water to it so the bottle is completely full. Now, stopper the bottle tightly with a cork that has a glass tube through it. And invite a friend to drink the soda. He'll think it's easy, but wait till he tries. Because there is no air in the bottle, the soda cannot go up into the straw. No matter how hard your friend draws on it, he won't be able to drink. But if you take out the stopper and allow air to press down on the soda, then he can drink it easily. A gas has less pressure when it is moving than when it is still. And here's an interesting toy you can make that will show this to you. Cut a square of cardboard and stick a pin in its center. Then put the pin in a spool. Now, try to blow the cardboard off the spool. The harder you blow, the tighter the card sticks to the spool. That's because the moving air between the card and the spool has less pressure than the still air on the other side of the card. When you stop blowing, the card falls. Because the molecules of a gas are spread out, a gas can be pushed together or compressed. Here's a toy you can make that will show you this. To make it, you need a glass tube and a pencil that fits into it loosely. First, cut the ends off a potato, leaving a slice about 1 inch thick. Get the glass tube, and with one end of it, cut out a piece of potato. Leave the piece in the tube. Now, turn over the tube, and with the other end, cut out another piece of potato. Now, there is a plug of potato in each end of the tube, and there is some air, which is a gas, trapped between the two plugs. Now, get the pencil. Aim the tube at a target and push one of the potato plugs. The compressed air shoots the other plug out. Bullseye. Here's a scientific stunt you can try on your friends, and you can do it only because a gas can be compressed. Put the glass part of a medicine dropper through a one-holed rubber stopper. Attach a rubber tube about 8 inches long to the wide end of the dropper. Now put the cork tightly into a soda bottle that's about 2/3 full of water. Now, call over a friend. And ask him to test his lungs by blowing as many bubbles as he can through the water. What's the trick? Well, the more air your friend blows into the bottle, the more compressed gas there is in that little space above the water. And when he stops blowing, the compressed air presses down on the water and squirts it out. And your friend gets an unexpected shower. The more a gas is pushed together, the more pressure it exerts on its container. Because of that, there is a very surprising scientific stunt that you can do. Connect a small balloon to a large one. The neck of the large balloon is twisted so that air cannot go from one balloon to the other. Now, what do you think will happen if we untwist the large balloon? Surprisingly, the small balloon blows up the large one. Why? Well, the air in the small balloon is squeezed together more than the air in the large balloon, so it exerts more pressure on its container. When you allow the air to go from one balloon to the other, the air from the small balloon is pushed into the large one until the pressure in both is the same. Now, we know that a gas can be pushed together or compressed, and that when it is compressed, it pushes back against its container. But a gas can be pushed together by something other than pressure. And here's an experiment you can do that will show you what that is. Place a balloon on a ring and rest a stick on top of it. Now, let's take a hose and run some cold water on the balloon. The balloon becomes smaller. Now, turn on the hot water and put it on the balloon. The balloon becomes larger. So we see that there is something besides pressure that can make a gas expand or become smaller. And that something is temperature. When you pour hot water on the balloon, the molecules of the gas inside move around more, and the gas expands. When you put cold water on the balloon, the molecules of the gas inside move around less, and the gas contracts, becomes smaller. And now you know a great deal about gases and have many interesting scientific stunts to do as soon as you get the chance.
Ask a friend to float a cork in the center of a glass of water. He'll think it's easy, but he'll find that it always goes to the side. Would you like to know how to make it work? Then keep watching.
Hello, young neighbors. Welcome to Junior Science. Today, we're going to talk about liquids. First, what is a liquid? Well, for one thing, it's something that flows freely and takes the shape of the container into which it is poured. Solids have a shape of their own and do not need a container. Well, now that we know what a liquid is, let's find out some of its properties. Here's an experiment that will show you one of them. Get a can and punch 4 holes in it at the same level. Pour water into the can. The water flows out of the holes in 4 streams, as you'd expect. But now try this. Run your finger across the 4 holes, and suddenly, the 4 streams become one. Why? Because molecules of a liquid, when given a chance, try to hold on to each other. This tendency of the molecules of a liquid to hold on to each other is called surface tension. And because liquids have surface tension, you can show your friends some amazing scientific tricks. For example, you can put a thin piece of cloth over a glass of water and turn the glass over without spilling a drop. Really, you can do it. All you have to do is wet the cloth before putting it on the glass. The molecules of liquid on the cloth hold on to each other, and the cloth acts like a solid surface. When you turn the glass over, air pressure pushes up on the cloth and keeps it in place, and the water in the glass does not fall out. Because of surface tension, a liquid forms a skin on its surface, and because of this skin, you can show your friends a very interesting stunt. Pour water into a glass until the glass is almost full. Now, challenge a friend to place a cork in the center of the glass and make it stay there. He'll think it's easy. But no matter how many times he tries, the cork always moves toward the side of the glass. When he gives up, you show him how. All you do is add more water to the glass. The liquid forms a rounded surface tension skin, which pulls the cork toward the center. When you put your hand into water, it becomes wet, because water molecules are attracted more strongly to your hand than they are to each other. But there is a way you can put your hand into water without getting it wet. Just do this. Drop a marble into a bowl of water and ask a friend to take out the marble without getting his hand wet. He'll try to figure it out. But no matter how hard he tries, he'll have to admit that he just doesn't know. So, you show him. Just get some lycopodium powder. You can get it at a drugstore. Sprinkle the powder over the water. Now, put your hand in the water and lift out the marble. Your hand will be covered with powder, but it will be absolutely dry, because water has surface tension, and the water molecules are attracted more to each other than they are to the lycopodium powder. Surface tension skins can be broken by many substances. One of them is camphor. If you want to see camphor break surface tension, just put some bits of camphor on the surface of some clean, cold water. The bits of camphor dart about merrily because they break a part of the surface tension skin near them and are pulled by the rest of the skin. Now let's find out something else about liquids. Here's an experiment that will show it to you. First, lay a folded towel in a pan and put a piece of paper on top of the towel. Now take a small, empty, flat-sided bottle and cork it. You can hammer the cork into the bottle easily. But now, fill the bottle with a liquid, cork it, and put a handkerchief around the neck of the bottle. Hold the handkerchief and hit the cork. The bottle shatters. That shows us another property of liquids. They cannot be compressed. Instead, they transmit pressure to their containers. Now, here's another fact about liquids. When an object is put into a liquid, the liquid pushes or buoys it up. The amount with which a liquid pushes up on an object is equal to the weight of the liquid that the object displaces. And knowing that, here's a puzzle that you may be able to solve. Here is a jar of water. Now, if you put your hand in the jar without touching the sides or the bottom, will the jar weigh more or the same amount? Let's first weigh the jar of water without your hand in it. It weighs 6 pounds. Now, put your hand in the jar, and we see that the jar weighs more, almost 7 pounds. Why? Well, when you put your hand in the water pushes up on it, tries to buoy it up. But you are holding your hand, so it can't be pushed up. Therefore, in effect, the push goes down against the scale. That's a puzzle that you can try on your friends, and they'll hardly ever give you the right answer. Now then, let's find out something else about liquids. Blow up a small balloon and tie a short cord to it. Now, swing the balloon into a stream of water. And it will stay there. Why does this happen? Well, here's an experiment you can try which will show you. Anchor 2 toy boats with strings and place them so that they float alongside each other. Then take one end of a hose and run a stream between the 2 boats. Instead of being pushed apart by the stream, the boats come together. That's because the pressure is less inside liquids that are moving rapidly than it is in liquids that are still or that are moving slowly. Because of that fact, here are a few very interesting stunts you can do. First, attach a funnel to the hose. Now, if you hold the funnel upside down and put a small rubber ball in it, the ball falls because gravity pulls it down. But here's how you can defy gravity. Turn on the water. Now put the ball in the funnel. The ball defies gravity and stays in the funnel. This is because the fast-moving water at the walls of the funnel is under low pressure, and the ball is pushed against the funnel by the greater pressure of the slow-moving water around it. If you turn off the water, the ball falls. Here's another scientific stunt you can do because a fast-moving liquid has less pressure than one that is still or that is moving slowly. Place a fresh egg in a glass of water. It sinks to the bottom. Now, challenge a friend to raise the egg by pouring water on it. He'll think it can't be done. But you show him. Just place the glass under a faucet and turn on the water. Instead of being pinned down by the flow, the egg rises because the fast-moving water over and around the egg actually has less pressure than the still liquid underneath it. And now you know much more about liquids than you did before. And you have many interesting scientific stunts to try as soon as you get the chance.